Okay, so good evening, everyone. This is our third physics class. So the topic today will be electricity and not electricity, sorry, electromagnetism and also electronics. Okay, so chapter 4 and chapter 5. Now let's look at electromagnetism. When you look at the word electromagnetism, the first part electro, it means like relating to electricity, whereas the second part is magnetism. That means it's like the magnetic field, everything lah. So we have already discovered that the magnetic fields, magnetism is related to electricity as well. So let's have a deeper look inside how does this like kind of affect it lah. Okay, so force on a current carrying conductor in the magnetic field. Okay, so basically we discovered that when there's a current passing through a conductor like a wire or metal, there will be magnetic field. Okay, how do you determine the direction of the magnetic field? You use the right hand grip rule lah, your right hand lah. Okay, right hand grip rule. You look, this thumb will be pointing to the direction of the current. If my thumb is moving up, so you see this is the direction of where the magnetic field will go lah, which is anti-clockwise. Okay, if it's pointing here in front, the electricity is moving here, so the magnetic field will be also anti-clockwise like this lah. Like this lah. So it depends on the direction of the wire of the current, where is it flowing. Okay, so a catapult field is a resultant magnetic field produced by the interaction between the magnetic field from a current carrying conductor and the magnetic field from a permanent magnet. That means, remember, magnetic field lines always travel from North Pole to South Pole. So, you have the permanent magnet punya magnetic field, and then you have the wire punya magnetic field. So, both of these field combined together, you will get your catapult field. Okay, so before we move on, you just have to see this bright info over here. When you see there's a wire is a dot like that, that means direction of current out of the plane of the paper. Okay, that means it's moving towards you lah, it's pointing towards you, the current is moving towards you. Okay, if you see an X across, that means direction of current into the plane of paper, that means away from you into the paper like that lah. Okay, so you already have this current, and then you have your permanent magnet punya field lah. So you see which one is stronger. The one below will be stronger because it's in the same direction. Both the field is in the same direction. That's why, okay, that's why bottom here there will be more lines. You see down here, formation of catapult field will be more lines compared to the up one. Upper is weaker. That's why the force is from the strong region to the weak region. Can you understand this one? The right hand grip rule and also the catapult field. So every wire around you, it carries the current, electric current. It actually produces a very weak magnetic field. Okay? Okay, yeah? Okay, good. Now let's continue to Fleming's left hand rule. Okay, so you have your right hand grip rule to determine the magnetic field. But what if from here, I want to find out the direction of the force? If you want to draw catapult field, it's possible, but it takes quite a long time. So the easier way is you use the Fleming's left hand rule. Remember, when it is when there's a power supply or battery and it is a current lah, okay, it's not an induced current, it's a current with the battery and power supply, you will use your left hand rule. Okay, Fleming's left hand rule. Okay, so Fleming's left hand rule, look at the camera over here. You have your three fingers, your thumb, and then your index finger, and then your middle finger. Okay, so it will always be at 90 degrees like that. Okay, first of all, your thumb is moving upwards, index finger to the front, and then your middle finger will be to the right. Okay, so this is your Fleming's left hand rule. Okay, then how you remember? You just remember FBI. Okay, FBI. So F will be force, B will be magnetic field, and then I, your middle finger, will be current. Okay, so how do you adjust your Fleming's left hand rule, your hand, according to the situation? Now you see, for example, over here, okay, Let's say they don't tell you the force. They only give you the magnet and also the current. So you see, the magnet from here is north, here is south. So that means your magnetic field will be moving from the left to the right lah. And then your current will be moving in this direction lah, out lah, towards you lah. So the force automatically you see here will be on top, moving up already lah. Okay? Can you understand? Boleh ya macam ni. Good. Okay. Very easy only actually. That's why I say electromagnetism is easy. Now we have a few factors affecting this strength of the of the magnetic field lah. Okay. So okay, basically that means if you have a higher current, that means you'll produce a larger force lah. Because if you have a higher current or higher magnetic field strength, then you will have a larger force lah. Okay. So you see, in this case, you have to use to determine like where the rod will move, original position of the conductor or the rod lah. So the force will push it, but you have to determine the direction of the force first. So you see the current is moving from the bottom one to the top one. So your current is somewhere like moving up like that lah. Okay. And then your magnetic field, how? North to south, bottom to up. So that means like this. Okay. Your magnetic field from bottom is moving up. Your current is moving like this. Okay. So your force will be moving to the right. So you see the track will push to the right lah, because your force is here. Your magnetic field is going up, your current is going like this. Can you understand this situation? Figure 4.7. Okay, so basically there's a coil. This is a conductor, a wire, and then they'll coil it into this different, to form like this big rectangle lah. Okay. So this is where the fun part ready lah. Okay. So you see the coil, you have your north pole and your south pole magnet. Okay. So your current, this will be the coil lah. Okay. Okay. Current is moving like this and then moving here. Okay. That means one loop like that. Okay. AB. And then this one is CD. North pole magnet, south pole magnet. Okay. So magnetic field line, magnetic field, remember, is moving like that. From the north to the south, magnetic field line. Okay. You want to determine which direction this will spin. Okay. So you need to find where is the force. You have your current, you have your magnetic field. So you have to determine the force. Now we look at this part first for AB. Okay. For AB, how is the current? AB, Fleming's left-hand rule, current moving like this. Magnetic field moving over here from the right to the left. Current is heading towards here. So you see your Fleming's left-hand rule, your force, your thumb will be pushing upwards. So that's why the force for this side is going upwards lah. Okay. So the opposite thing over here, your current now is flowing like this. Your current is flowing like this, but the magnetic field is moving like this. Okay. Your magnetic field is going over here. Your current is coming down like this. Hold on, how do I adjust my finger? Hold on. Okay, like this, and then moving like this. Okay. So your force will move down. Your thumb is pointing downwards. That's why the force is going down. So AB punya side akan naik. CD punya side akan turun. So it will turn like this lah. Can you understand? This is AB side, this is CD side. So here go up, here go down. So it will turn like this lah. It will turn and turn and turn like this. Can you understand? This is the function of how the mechanism of the motor lah. Faham ke macam ni? This is how it keeps continuously turning lah, because the interaction between your magnetic field and the current, you will produce the force to turn, and then you have to determine how it turns. If let's say I switch position, I switch the position. Okay, let's say current saya maintain current, tapi I switch magnet. Okay, I switch magnet. here north, here south. Okay, can you tell me AB side force go up atau force go down? AB side force go up atau force go down? AB punya side, you see look at the diagram carefully. I switch the magnet. AB side down ke up? Down, good. Okay, and then the CD side up, good. So dia macam mana dia akan turn? Dia akan turn macam ni lah. Okay, so like this, it will turn like that. Here going down, here going up, like that. Okay, so okay, let's say maintain the magnet like that. Change the direction of the current. So you see everything, you just use your Fleming's left hand rule. Okay, let's say the current is flowing like this lah, like this, and like this. Okay, another person besides Sabrina, you tell the answer for AB dulu. AB, how? Use your Fleming's left hand rule. Is it moving up or down the force? Up, good. This one, CD side, not up, okay, down. Okay, moving down. So it will rotate like that. Can you understand? If you understand this, then good, ready lah. Okay. So this is how you use the Fleming's left hand rule. Okay, direct current motor. So this is how you use the mechanism of the motor lah. Okay, so the same thing only. This thing is actually applied in the motor. The same thing lah. Okay, so you see, first half rotation. Carbon brush X in contact with red half of commutator. Carbon brush Y in contact with blue half of commutator. Direction of current is from the ABCD, the direction. Okay, side AB force act downward, side CD force act upward. So coil rotate in the one direction. Okay, second half rotation. You rotate half ready. Okay, carbon brush X in contact with blue. Carbon brush Y in contact with red half. So the direction of current, actually the arrow here is draw wrong already. I don't know why they go and draw wrong. Okay, so okay, not to say draw wrong, sorry, it's like you see the changes to the alphabet. Okay, changes to alphabet, so that means it will DCBA lah. Okay, the current is like the current, you just ikut saja the current macam tu, and then you will use your Fleming's left hand rule to find the force, direction of force lah. Okay, so it will rotate and rotate and rotate. Can you understand the mechanism? Boleh ya? Motor boleh faham ya? Mechanism of motor. How does motor function? Okay, good. Now, factors affecting speed of rotation of electric motor. When rotation of motor increases, because speed of rotation increases. What does it mean speed of rotation increases? That means more force lah. If your force is very weak, it will turn very slowly lah. But when the force is strong, it will turn very quickly lah. Okay, so current in the coil increases. Strength of the magnetic field increases. Coil with more turns is used. Your coil is more turn is used. That means your electromagnetic flux will cut even more lah. When you cut more electromagnetic flux, remember this EMF, this electromagnetic flux is not the electromotive force. This is electromagnetic flux. Okay. So it will cut more electromagnetic flux if you use more coil. Okay. Okay, so brushless motor, brush motor. Okay, similarity and differences. As a magnet and a coil use magnetic force to produce rotation. Differences is brushless is coil is stationary, the magnet akan rotate. Tapi untuk brush motor, magnet stationary, coil akan rotate. No carbon brushes, no friction. Okay, brush motor, ada carbon brush, ada friction. Sparking, no sparking and commutator for brushless, sparking and commutator for brush. Soft operational sound, louder operational sound lah. Okay. Okay, that's all for like how to say, normal current lah. Okay, now we move on to electromagnetic induction. What does it mean, induction? Induction means you will produce an induced current. What does it mean, induced current? Meaning you don't have battery, you don't have power source, but you still have your wire and your magnetic field. Okay, you have your wire and magnetic field. So the interaction between your wire and magnetic field can produce an induced current lah. You understand? So doesn't necessarily mean you must have your battery only can produce current. No. If you have magnetic field, magnet, and then your wire, you move it, only then you can produce an induced current. Okay? So you see here. Okay. When a piece of copper wire is moved across magnetic flux, okay, an electromotive force EMF is induced in the wire. The phenomenon is known as electromagnetic induction. Okay, that means you produce the induced current. Okay, it's corrected to form a complete circuit. Deflection of galvanometer pointer is observed as shown. Okay, so that means actually what is magnetic flux? Magnetic flux mean, remember when the, how to say, okay, remember when here is the north, okay, north, here is like the north magnet, here is the south pole of the magnet. You move to north and south, right, your magnetic field lines. Okay, so when I take a specific region, okay, it's like cutting the line. This is what we call as magnetic flux. A conductor that moves and cuts magnetic field lines can be said to cut magnetic flux. Okay, this is what we call magnetic flux. The magnetic field line that pass through a surface. Like this here, for example, is a surface. This is what we call cut magnetic flux. So, how to produce an induced current? You have to move either your magnet, move the magnet, or you move the wire. Because like this, you can only produce movement. Let's say you see figure 4.18. You move the wire. When you move the wire, it will cut the it will cut the magnetic flux. That's why you can produce induced current. Okay. For the figure 4.19, you move the magnet. Okay. Instead of moving the wire, you move the magnet. That's why dia akan cut magnetic flux. Okay, instead of moving the wire like that. Okay, later on we'll learn how to use the Fleming's right hand rule. Okay, when a bar magnet is moved towards or away from a solenoid, the turns of the solenoid cut the magnetic field lines. Okay, different name for which one? Sorry, the current, is it? Magnetic flux. Not to say different name lah. Okay, it's like referring to like how to say, the magnetic field that passes through this surface region. Okay, we call it magnetic flux. So normally when we cut, we don't say we cut magnetic field. We will say we cut the magnetic flux. Like a term like that. You have to say a specific term. Okay. Okay, so the end of the solenoid. So that means you see, when you don't necessarily need a straight wire and also a magnet. You can have a magnet and also your solenoid. Okay, when you have your magnet and your solenoid, you move towards each other, it also will produce an induced EMF, an induced current. Okay, so let's look at the definition of electromagnetic induction. Production of an induced EMF in a conductor when there is relative motion between conductor and the magnetic field, or when the conductor is in a changing magnetic field. That means as long as there is a motion of the wire or motion of the magnet, it will produce an induced EMF. This is what we call induced current. Can you understand? Okay, so you have to move your magnet or you move your wire, your conductor. Okay, now we look at the factors. So it's the same thing, the factor. So you see, relative motion of a straight wire and also and magnet. Induced EMF increases when speed of relative motion increases. When I increase the speed of relative motion, okay, I increase the speed of the wire, the EMF induced current produced will be larger, and the strength of the magnetic field also increases. Okay, because remember, you have your force, you have your magnetic field, and then you have your current. Okay, so when you increase the one of it will increase the others. Okay, For solenoid, it's the same thing, but one more extra is the number of turns of the solenoid increases. When you increase the number of turns, like I said just now, you will cut more magnetic flux. Okay? When you increase the turn, let's say this solenoid, very less only, compared to like this solenoid, a lot of coils. Okay, so it will cut more magnetic flux. That's why it is, how to say, it will be stronger lah. Okay, strength of the magnetic field increases, and also your induced EMF akan larger lah. Okay, so now we are introduced to Faraday's law, which is by Michael Faraday. So states that the magnetic of induced EMF is directly proportional to the rate of cutting of magnetic flux. That means, kalau rate of cutting of magnetic flux higher, that means magnitude of induced EMF is higher lah. I akan produce lagi banyak induced EMF lah. Okay? Faham ya, Faraday? Okay, direction of induced current in a straight wire and solenoid. Okay, so now we are introduced to the Fleming's right-hand rule. Just now, ada battery, ada power source. That one is normal current. You use Fleming's left-hand rule. But now remember, no power source, no battery. You will produce an induced current. You use your Fleming's right-hand rule. Don't confuse, okay? Right-hand rule. Okay, so how the same thing lah, FBI, this one will be force, this one will be magnetic field, this one will be current, FBI, okay? So, another law is Lenz's law. Okay, Lenz's law is very interesting because you see, states that the induced current always flow in a direction that opposes the change of magnetic flux that causes it. Okay, what does it mean? You look at example. Okay, you look at an example. Okay, solenoid, remember the solenoid wire, dia akan flow from the north to the south, ya, solenoid punya wire. So, magnet is pushed towards solenoid. Induced current produce a north pole at the end of the solenoid to repel the magnet moving towards the solenoid. That means, okay, situation 1, my solenoid, kalau sini solenoid is north, when my, actually, we should focus on the magnet first. Okay, here is north, here is south. When my magnet, I move towards the solenoid, solenoid akan try to repel. How to repel? The same pole lah. So, solenoid sini akan produce north pole. Sini jadi south pole. That's why the current will flow from here. Okay, will flow from here to here. Can you understand? This is the first situation for Lenz's law. Magnet saya, north pole saya masuk dekat-dekat, solenoid akan produce north pole. Automatically here changes to north pole because I want to repel the magnet. Okay? Second situation, kalau north pole, I move away. Okay? Second situation, north pole, I move away. When north pole move away, you don't have to repel, right? So here akan jadi south lah, here north. So how does the wire, the current move from here, this north to here south lah? Okay, I move away. Magnet saya move away from solenoid, so sini akan jadi south lah. Okay, and then the same thing happens for the rest. Okay, solenoid again. And then you have your, let's say your magnet south pole pergi dekat. It wants to repel the magnet. So here automatically jadi S, south. Here north. So it flows from here to here lah. But if I move my south, okay, I move my south away from the solenoid, here becomes north. Here is south. So the current flow like this lah. Okay, so this is Lenz's law. Can you understand? How fast does it change its poles though? That immediately lah. If I push fast, it's gonna change at the same rate. Yes, that's why you see, when you push it, there is relative motion. When there is relative motion, there will be a change in the magnetic field, which produces the induced current lah. speed of light. Ayo, you that fast, man. Okay. But remember, because you push, go in and go out a lot of times, push towards and away from it. That's why it will produce a changing magnetic field, and then it will produce the induced current lah. Okay, it will produce the induced current. This is how you use the solenoid and the magnet. Can you all understand Lenz's law? Very easy only actually. This chapter is very fun lah actually. Very fun and interesting. Can do very fun activities in the lab. And less formula also. Actually, this chapter, you don't have to calculate much except for transformer only. You don't have to calculate all this one. No formula to calculate all this. All this is concept only. Okay? Boleh ya? I hope you all understand ya, the concept. Okay, direct current generator and alternating current generator. So this will be referring to the dynamo lah. Okay, now you look at the difference. Okay, direct current is the similar to just now how we learned the direct current lah. Okay, you have a carbon brush, but this one will be slip ring lah. Okay, so the similarities is it uses electromagnetic induction. Coil is rotated by an external force. Coil cuts the magnetic flux. EMS is induced in the coil. But you see, to produce direct current, that means it will be in one direction only, and it will be, how to say, like direct current means like this lah. Okay, the graph dia akan straight line. Macam ni lah direct current. Okay, for this alternating current, your graph macam ni, so dia akan positive, negative like that lah. Okay, this is alternating current. Later on in electronics also, we will see the graph more clearly lah. Okay, so ends of the coil are connected to split ring in commutator, whereas ends of the coil are connected to two slip rings in AC generator. Okay, two sections of the commutator exchange contact with the carbon brush every half rotation. Slip rings are connected to the same carbon brush lah, always connected to the same carbon brush. Okay, output is direct current, output is AC lah, alternating current. Okay, so that's all lah for electromagnetic induction. Your a few laws lah. You have your Fleming's left hand rule, Fleming right hand rule, right hand grip rule, Faraday's law, and Lenz's law. Okay. Now let's look at the transformer, mechanism of transformer. Okay, transformer is important because it uses this concept of electromagnetic induction to produce the current at the necessary voltage. Okay, let's say from a small power output, I want to produce a larger voltage or a larger output, or maybe from a large one, I want to produce a small. So this is where you use your transformer. Okay, so step down, that means from large, you go become smaller. Step down is going downwards. Mobile phone charger lah, because your mobile phone require less electricity ma. Whereas your step up transformer, microwave iron, you need more. That's why from a small current output, you produce a large one. Okay, so let's look at the how is the structure and the mechanism lah. Okay, so simple transformer, it is made up of laminated soft iron core. Okay, we will see why is it laminated and soft later. Okay, you have your AC power supply, which is your input, and your output terminal. But you see, there will be leakage of magnetic flux. Your magnetic field is free, that's why it will flow outside and loose to the atmosphere. Okay, primary circuit, AC power supply produces an alternating current in the primary coil. Alternating current produces a magnetic field that changes in magnitude and direction. Okay, magnetic flux from the primary coil is linked to the secondary coil through the soft iron core. Okay, that means magnetic field produced from primary coil or primary circuit will connect to the magnetic flux of the secondary circuit or secondary coil. Understand? Both of them will interact together, but not 100% interact. Some of them will be free there will be a leakage. Okay, so in your secondary circuit, changing magnetic field induces an alternating voltage across the secondary coil. That's why your formula is Vs over Vp equals to Ns over Np. Okay, that means because of this change of magnetic field, it will produce an induced current lah. Okay. Ideal transformer. What does it mean, ideal transformer? Ideal transformer, that means, how to say, that means no power is lost lah. Okay, but we will have the formula to calculate the efficiency of the transformer, which is, I forget what this symbol is called already. Can you all remember? I forget what is it called already. Okay, output power over input power times 100%. Okay, theta. It's called theta, is it? Okay. Never mind, maybe later on, if I remember, I'll search it lah. Okay. Ideal transformer, transformer that does not experience any loss of energy. Efficiency is 100% lah. Okay. But of course, this one is so hard to get lah. Normally, it's always like you will lose some power to the surrounding. Okay. So, output power equals to input power. Same thing lah. Okay. Your formula for power is VI lah. From the chapter 3 just now you learned already. Okay. Now, okay. So these are two types of transformer. Okay, first of all, just now as I said, not every transformer, not to say not every transformer, all the transformer will at least lose a few energy except for or power, except for those like really efficient or ideal transformer lah. Okay, so the factors or causes of this energy loss is because of resistance of coils. That means this coil, of course, each wire you have your own resistance. That's why there will be, it will oppose the flow. Okay, primary and secondary coil consists of wire that are very long. When current flows in the coil which have resistance, heating of the wire occur. You heat, then your resistance will increase. That's why your heat energy will release to the surrounding. Okay, the second factor is because of eddy current. What does it mean, eddy current? Changing magnetic field induces eddy currents in the iron core. That means this magnetic field, besides the primary magnetic, besides your primary current induced to produce a secondary current, you also will have additional eddy currents at the side. Okay, you will have the eddy current, and this eddy current heat up the iron core. That's why it will release more heat energy to the surrounding. That's why you will lose the energy. Okay, the third factor is hysteresis. What does it mean, hysteresis? Iron core is magnetized and demagnetized continuously by the changing magnetic field. That means this iron core suddenly magnetized, demagnetized, magnetized, demagnetized. So energy supplied for magnetization is not fully recovered during demagnetization. Difference in energy is transferred to the iron core to heat it up. So you see, all of these factors, it will cause it to heat up the iron core and lose the energy through heat energy. So it's not good. Okay, the fourth factor is leakage of magnetic flux. Magnetic flux produced by primary current is not fully linked to the secondary coil. So you see, for this first type, your magnetic field is over here. Your secondary magnetic field over here. But not all of it is 100% used together. Okay, some of that will be loose. That's why it's called the leakage of magnetic flux. Okay, but this second type is better because you see, all are linked together and the magnetic field is together. That's why the magnetic flux will be used more efficiently. Okay, now you know already the factors. Let's look at the ways to overcome these factors. Okay, so how to overcome this resistance of coils? You use a thicker copper wire so the resistance is smaller. Remember, your formula in your previous chapter, R equals to rho L over A. So that means the higher the larger the area, the smaller the resistance. Okay. So your larger area, you'll produce less resistance. Okay. Eddy current. You see, why they use laminated is because use a laminated iron core that consists of thin iron sheets glued together with insulation glue. Because of this laminate, it can reduce the changing magnetic field and also it won't heat up easily. Laminated. How about soft iron core? Soft because to prevent hysteresis, which is the magnetization and demagnetization. That's why it requires a smaller amount of energy to be magnetized. That's why it's important why you have to use laminated and also soft iron core. Okay, laminated is because for eddy current, soft is because of hysteresis. Now, how do you overcome leakage of magnetic flux? So you see, So I've already drawn the diagram. This is how you overcome lah. So secondary coil is wound on the primary coil so that all the magnetic flux produced by the primary current will pass through to the secondary coil. So this is less efficient. This is much more better. Okay, this is better lah. Can you understand this transformer thing? You won't remember. You won't remember which one. Is it the factors? Is it or the steps? The steps and factor you have to kind of memorize yourself lah. But ini paling important. Mechanism of how it works. You must know. Mechanism you must know. If you understand the concept, good enough already. And also formula lah. Your Vs over Vp equals to Ns over Np lah. Okay. Your P in, P out over P in times 100% is your efficiency lah. So actually eddy current, there's also its uses lah. So you see eddy current here also can be used to heat up the base of your pan lah for an induction cooker lah. Okay. So use of transformer in daily life, step down, that means from higher energy source to lower energy output. For example, what? Computer charger, photocopy machine, welding machine. Step up, that means you need more energy, microwave oven, defibrillator, and x-ray machine. Okay, now, solving the problem. How? Okay, transformer is connected to 240 volt power supply, supplies 27 watt of power at a voltage of 18 volt to an electronic component. Okay, so assuming the transformer is ideal, that means no energy is lost. So you already have your V in. Your V in, not V in, your V primary, okay? Your VP is 240. Your VS is 18. Okay, how about the N? The N, they give you NS is 60 lah. So you have to find your NP berapa lah. Okay, so your NP is 800. Okay, when your number of coil is higher, you have more number of coil, your voltage akan higher lah. When the N is smaller, your voltage will be smaller lah. Okay. Okay, already calculate number of turn, then calculate the current in the secondary circuit. So you have your watt already, you have your power, so you have your voltage as well. You just calculate the current 1.5 ampere. Calculate current in primary circuit is the same thing lah, because the power, remember, power is always the same. Okay, you don't lose any energy, your power is the same lah. Okay. Okay, so you get 0.1125 ampere. Okay, understand? Okay. Now, I think this is, the last one is the electrical energy transmission. Okay, so energy transmission, you see, from the power station, okay, power station, they produce only 20 kilovolt, but they will have a step-up transformer to increase its voltage a lot, and then will supply through the power lines. And then when it comes to the distribution, the substation will have step-down transformer to reduce the voltage lah. And then you will reduce again lah, especially to residential home. Out of 132 kilovolt, you only use 230 volt. So it will reduce a lot. For light industry, it will reduce to 11 kilovolt. Heavy industry to 33 kilovolt lah. Okay, understand? So step-up transformer are used to increase the voltage in the power cable. Okay, why do we increase the voltage of power cable? Is because we want to reduce the current. If you reduce the current, you will have a smaller loss of energy, because small current mah. If kalau small current, that means small loss of energy lah. That means dia akan lebih efficient lah. During distribution of electrical energy, step-down transformer are used to decrease voltage to a suitable value for industrial and residential consumer. Can you understand? So that's all lah for electromagnetism. Actually, very easy only, right? Does it take energy to run a transformer? You have to supply the power lah. Okay, you supply the power over here, the voltage. Then it will automatically supply the other voltage already. Okay, from primary, you supply the voltage here already, so it will produce the secondary current lah. Okay, before I move on, let's just do a quick activity. Okay, this number 3, you see. Okay, the current is moving like here to here. Okay, so that means, how to say? Okay, tell me what this X over here is what pole? The current is moving like this. This X here is what pole? Is it north or south pole? This X. You look at the current like that, right? Okay. So the X how? Okay. You don't actually need to know the magnet moving because they give you direction of the current. They give you the direction of the current. So from the direction of the current, you can determine the pole lah. And then once you determine the pole, only I will ask lah, where is the magnet moving lah, towards or away lah. Okay, X is not good. So if X is not, that means the magnet is moving towards or away from the solenoid. Towards, good. So Y here is out lah. That's why it's moving away from the solenoid. Good. Okay, now we go to chapter 5, electronic. Honestly, this chapter also, you have to read and memorize a lot lah. Okay, not my favorite chapter also. Okay, okay, first of all, you are introduced to thermionic emission and cathode ray tube lah. Okay, so this is a cathode ray tube. Okay, you look at here, you have your positive and negative. Okay, negative here, okay, will be your cathode, positive is anode lah. Okay, so because of this negative, you have a lot of electron here, negatively charged. Okay, your cathode is negatively charged. So when you turn on the power supply, EHT power supply, okay, electrons will escape lah from the cathode to the anode. Okay, it will be attracted to the anode, which is positive. That's why this beam over here is called the cathode ray lah. Okay, this is called a cathode ray, and this phenomenon is thermionic emission. That means I supply the electricity, will heat up the thing, and then will release the electron. This is called thermionic emission. Okay, so let's look at okay. There are many free electrons in a metal wire. For example, tungsten filament. When the 6-volt DC power supply is switched on, temperature of the tungsten filament will rise and the free electrons will gain sufficient kinetic energy to leave the metal surface. Thermionic emission is the emission of free electrons from a heated metal surface. Okay, your metal surface over here, you heat it up with enough heat energy, and then there will be thermionic emission lah. Electrons will escape lah. In a glass vacuum tube, electrons are able to accelerate towards the anode without colliding with air molecules lah. That's why there will be maximum velocity, maximum kinetic energy lah, because there is no friction or air resistance ma. It's a vacuum. Okay. When a vacuum tube is connected to an EHT power supply, electrons emitted from the cathode will be attracted to the anode at high velocity to form an electron beam. This high velocity electron beam is known as cathode ray. Okay, electron beam will complete the EHT power supply circuit and millimeter reading will show that a current is flowing. Okay, so very easy only, just the concept. If the connection to the EHT power supply is reversed, millimeter will not show any reading lah. Because your anode don't have electron. Your cathode yang akan electron. Okay, that's why it will flow from the cathode to the anode. Effects of electric field and magnetic field on cathode ray. Okay. Cathode rays are beams of electron moving at high speed in a vacuum. Okay, so this is like, there are two experiments to like, how to say, or two activity just to show the characteristic lah. So electron is negatively charged, it will attracted to the positive plate. Okay, so you have the fluorescent grid and also you have the Maltese cross tube. Okay, now let's analyze it and see what does it mean. Okay, when I use a deflection tube, okay, when I use a deflection tube, this is, okay, we go slowly lah, okay. S1 and, wait, where is it? S1 and S2, okay, over here. S1, S2 turn on. Okay, I turn on these two. Remember, EHT power supply is to turn on this to complete this entire circuit. S1 over here is to hit the cathode. Kalau saya turn on the 6 volt S1, dia hit saja thermionic emission. Tapi not necessarily dia akan connect kepada anode. Can you understand? Because there's no current in EHT power supply. If I turn on S1 only. If I turn on S2, okay, there is also no current because I hanya activate cathode dengan anode, tapi I tak ada S1 to activate to heat up the cathode. Can you understand so far? S1 and S2, what is the difference? Which switch? What is the function of the different switch? Okay, I repeat lah. Okay, so you see, okay, I use this better. You have two switch. One is your 6 volt power supply punya switch, your S1. One is your EHT power supply punya switch, your S2. S1 function dia hanya untuk heat up the cathode. You see this thing? It will heat up the cathode. That's why it will produce thermionic emission. Okay? S2, the function of EHT power supply is to complete the circuit, activate your cathode and anode, so the electron will flow from the cathode to the anode. Kalau saya turn on S1 sahaja, okay, you heat up the cathode, dia akan produce thermionic emission. Tapi dia tak akan necessarily attract to the anode. Okay, they can go anywhere lah because this circuit is not complete. Okay, kalau I off this circuit, I off the S1, I switch on the S2, okay, there will be no thermionic emission because I don't have S1 to heat up the cathode. Okay? Okay, yeah? Then, so you see, if I on S1, S2, there will be thermionic emission, so it's just like that, a straight line. Okay? But if I turn on S3, this S3 is to complete the circuit for this tube. That means it will show lah, okay, the above one is positive, below one is negative. So it will go up lah to the positive one because it's attracted to the positive plate. Because electron negatively charged that's why it attracts to the positive lah. Cathode ray can be deflected by an electric field. They are deflected towards the positive plate, okay, in a parabolic path. Cathode rays are negatively charged because they consist of electrons, okay. Now, how about Maltese cross tube? Okay, look at the S1, S2, okay. S1 heat up already. S2 activate not just this circuit, EHT power supply, but also will activate the Maltese cross. Now we see. If I activate S1 only, there will be, what is it called? There will be like a thermionic emission. Light from the hot tungsten filament is be blocked by an opaque object, Maltese cross to form a shadow. Okay. When I turn on the S2, there will be the cathode ray will form lah. Okay, so cathode ray are blocked by Maltese cross to form a shadow. Cathode ray travel in a straight line. Cathode ray also produce a fluorescent effect on the screen surrounding the shadow. This show that cathode ray possess momentum and kinetic energy. Now, if I turn on and I use the magnet, okay, this is where it gets a little bit complicated. Okay, so bear with me lah. Okay, bear with me. So the north pole is dekat the Maltese cross tube. One shadow is due to the light from the hot tungsten filament, your S1. The other one is due to the deflection of the cathode ray by the bar magnet that is placed in the tube. The deflection cathode ray can be determined by Fleming's left-hand rule. Okay, so how do I explain this? Let me visualize it. Okay, so this is your north. Okay, so so this is your what is it called? The cathode ray tube. Okay, so this will be your Maltese cross. Your shadow, one shadow will be over here like that. Okay, the other one will be downwards. Okay, now why is the other shadow downwards? Okay, it's because you have your magnet here, north, south. So north pole over here lah. Now, use your Fleming's left-hand rule. You know the current is flowing from here to here. Okay? Your current, your electron is flowing from here to here. Okay? This is your current. Your magnetic field, how? North so moving here lah, north. Okay? So this is your B. Okay. Now you want to determine the direction of the force. So, use your Fleming's left-hand rule. Okay? Current moving like this. Wait, did I do it the wrong way? Hold on. Okay. This one and then wait, did I think I put the magnet the wrong side. Whoops. Okay, north south this side. Okay, magnet this side. So current like this, the magnet is going here. So when I put the magnet like that, the force is going where? Where is the force going? Which direction is the force? Can you use your Fleming's left-hand rule to determine where is the force going? Magnetic field going here, current like that. Where is your force? Up, are you sure? Are you using the wrong hand? Fleming's left-hand rule here, because you have your power supply, your what is it? Your magnetic field is moving to the right. your electric current is moving like this from here to here. Cannot lah. Okay, so the answer is down. Okay, because you see, your F, the one now. Okay, look at my finger. Okay, look at my finger. Your I is moving like this towards here. Your B is moving to the right, from the left to the right. Okay, your I moving inside, your B here, so your F, your thumb is pointing downwards lah. Okay, your thumb is pointing downwards. That's why the force is moving down. Because of this force pushing down, that's why the cathode ray, dia akan bend ke bawah. You pushing the cathode ray bawah. That's why it will produce the shadow downwards lah. So let's continue. Okay, velocity of an electron in cathode ray tube. Okay, so basically, your first formula is energy equals to EV lah. Okay, E equals to EV. Okay, that means the number of electron times the voltage of each electron lah, potential difference, charge of an electron times the potential difference between the cathode and the anode lah. Let's say the potential difference they give you the charge of electron, they want you to find the energy lah. Okay, when EHT power supply, okay, then you have your maximum velocity. So remember, your first equation, energy is like this. Okay, electron charge times the potential difference. Okay, and then energy is also kinetic energy. What is formula for kinetic energy? Half mv squared. So you can relate the two. EV is equals to half mv squared. Okay, so this is how you determine the velocity lah, maximum velocity of the electron. Okay, now look at this question. Figure shows an electron beam accelerated from the cathode to the anode in the vacuum. The potential difference across the cathode to the anode is 550. They already give you the V. Okay, they give you the mass of the electron. They give you the charge of the electron. So your M already given, your V already, your capital V already given, your E already given. Okay, what is the electrical potential energy? You just want to find energy. So they already give you, the question already give you 550 volt lah. Okay. So you just times the E, then you get your answer lah. Okay. So this is your formula you use for the question A. Now, question B, what is the kinetic energy? Okay, remember, kinetic energy will also equal to the electrical potential energy. So it's the same thing lah. You see, 8.8 times 10 to the power -7. C baru you kena find the small v, maximum velocity. So you use your formula, EV equals to half mv square. Okay, and then you change here and there. Okay, 2 EV, and then you divide the m, and then you square root lah. Okay, so you get your answer 1.39 times 10 to the power 7 meter per second lah. Can you understand this formula? Actually, very easy only one. Okay, EV equals to half mv square. Electrical potential energy equals to kinetic energy. Principle of conservation of energy. Okay, now we move on more to the concept. So semiconductor diode. Okay, actually, I will have to admit lah, here a bit, I will struggle a bit to explain to you because it's a bit hard to find. Maybe we can later on Google the diagram lah, because it's a bit hard to explain to you, especially online. How do you form the positive and the negative punya holes and electron lah? Okay, tak apa. Okay, so semiconductor diode. Okay, so let's see what is the function. Basically, it's in an electronic component which allows electric current to flow in one direction only lah. That means semiconductor diode, it will force the electric current to flow in one direction lah. So you see for the first example, positive flow to negative. Okay, P to N. Okay, positive to negative. Kalau itu dia panggil forward bias. Okay, it will call forward bias. Actually, before I move on, let's look at how do you form the P layer and the N layer of the semiconductor diode. Okay, give me a while. sharing the screen. Okay, so look at the presentation. Okay, here. So the process of how do we form this positive and negative layer of this semiconductor is called doping. Okay, so what do you mean? Now, just now in the previous topic, you already learned semiconductor. Okay, semiconductor, it will be the materials used will be silicon or germanium lah. Okay, so to form a P semiconductor, your doping element is I will add boron. Okay, normally you will add boron. Okay, you can add boron or you can add what other elements ah? Give me a second. Arsenic, yeah, arsenic I think also can. Aluminium, is it? Yeah, aluminium also can. Okay, so we just use boron as example. Silicon atom has 4 valence electron. Boron you only have 3. So when you doping, you add boron dalam silicon punya crystal lattice. Okay, dia ada satu hole di sini because dia tak ada electron mah. There's no electron to fill in here because boron only has 3 valence electron. That's why here we call hole lah. That's why dia akan form positive punya layer lah, P-type semiconductor. Boleh faham ke? Can you understand this? Positive punya semiconductor, positive punya part. Ada hole. Why there is the hole there? Because of the doping lah. What elements? Boron, aluminium. Okay? No response one? Maybe. Okay, I repeat again. Okay, so basically, you see, or we look at other example. You see this boron. Silicon ada 4 valence electron. Boron ada 3 saja. That's why you see here, there is a hole here lah. There is a hole here because there's no electron lah. That's why this is positive loh. So you see, same thing over here. Okay, you put your boron over here. Actually, it shouldn't be germanium lah. I don't know why they put germanium. It should be the boron over here. That's why there will be hole here because there's no electron lah. You see, there's hole here. Okay, you put the boron, there is hole here. Okay, hole. Sini ada hole also because it's positive lah. Okay, and when you put aluminium, same thing, there's also a hole here. That's why it's called hole. How this is elaborated? Yes, exactly. I tell you, I was so upset. This was not in the textbook, you know. You should know actually how does it form the P-type or N-type semiconductor first, the doping process. So I'm very sad lah, okay. Another thing I'm sad is in biology, they didn't explain the types of protein lah, but it's okay. Anyway, if they don't test you in textbook, that means exam cannot keluar that one lah. Okay, but still you have to understand this for your comprehension lah. You have to understand the concept first lah. Okay, now this is for P. How about N? N means dia ada extra satu electron. Okay, N semiconductor. So you see, for example, SB is what is this? Is it antimony? If I'm not mistaken. Okay, so you see, okay, phosphorus or antimony. You see, they have 5 valence electron. Dia extra satu electron. That's why here ada free electron lah. That's why it's N-type semiconductor lah. You see, antimony extra satu. Apa lagi sini? You see, antimony SB extra satu. Okay. Lead also extra satu. Okay. AS is what? Is it astatinum or something like that lah? Okay. Arsenic, sorry. Arsenic, so extra satu. So elements for N-type semiconductor is lead, phosphorus, arsenic, and also antimony. Okay. For P-type, you will have your boron and aluminium lah. Okay. This is doping process lah. Okay. Okay. Now you already know how to form the positive and negative. Okay. Let's look back at the textbook. So when it's forward bias, that means like the current flow memang from positive to negative like that. There will be a current flow lah. That's why it's called forward bias lah. Holes will move towards the N-type semiconductor. Electrons will move toward P-type semiconductor. Okay. Depletion layer becomes thinner. The layer in between becomes thinner. Junction voltage across depletion layer decreases and resistance of diode becomes very small. That's why dia akan ada current lah. Because this layer becomes thinner. Okay. So the bulb will light up. Tapi kalau dia reverse bias, what does it mean reverse bias? That means positif, tapi sini dia jadi negatif. Negatif, positif. Macam ni, reverse bias. So no current lah. Kenapa? Because holes and electron will move away from the depletion layer in opposite direction. So depletion layer akan jadi lebih besar, thicker. Junction voltage increases, resistance increases. So there will be no current lah. Okay, so this is the mechanism of this semiconductor. Use of semiconductor diode and capacitor. Now, you have already learned semiconductor diode. Let's look at the second component we call a capacitor. Okay, so process of converting and alternating current into a direct current is known as rectification. So you can convert an alternating current to a direct current, but not the other way around. You cannot convert direct to alternating here. Okay, so there are two types of rectification, which is half wave and full wave. Okay, now half wave macam mana? You tengok. Complete cycle of alternating current consists of two half cycle. Positive half cycle and negative half cycle. Ingat, alternating current just now I draw, okay. Dia akan positive, negative, positive, negative. That's why it's called alternating lah, the wave. Okay. So, positive, during the positive half cycle, semiconductor diode is forward bias. Dia akan allow current to flow lah. But during negative half cycle, conductor diode is reverse bias, so there akan no current flow. That means only half cycle rectification lah, half wave. That means only the positive will be involved lah. Okay, so the current will be the positive punya lah. Can you understand? I hope you understand ya. Because kalau sini, you tengok sini, kalau sini produce positive current, dia ikut the semiconductor diode, it will produce lah the current. Tapi kalau sini negative, follow diode, dia tak akan produce because it's reverse bias. Okay. Full wave rectification berbeza is called a bridge rectifier. Okay. Full wave dia berbeza. You tengok kenapa. Positive half cycle, diodes D1 and D2 are forward bias. D3 and D4 reverse bias. Therefore, D1 and D2 allow current to flow while D3 and D4 prevent current from flowing. So you see, when it's positive, sini ke atas, you follow the cursor, okay? For positive half cycle, it goes one direction like this. Up, macam ni, okay? And then you will go past the D1, come here, come resistant, go up here. Remember, you will always go straight, okay? Okay, come here, turn straight, like that, like that, like that, like that, like that, go back. Okay, so dia akan pass through D1 and D2. Okay, negative how? Opposite direction. Follow the cursor. Like this, like this, like this. Okay, go past D3 macam tu. Resistant. Okay, straight like that. Okay, go past D4. Come back here. Like that. Okay, so for negative, you will use D3 and D4 lah. That's why this is called a full wave rectification, because positive half cycle, you akan use D1 and D2. Negative, you akan use D3 and D4. Both positive and negative is also used for the rectification. That's why you see the output waveform is like that lah. That means every half of the cycle is alternating lah. Dia akan switch lah. Positive dia akan macam ni, negative macam ni. Okay. Okay, so basically this is the current lah. Now, we can smooth this current. How do we use to smooth this current? Is use the capacitor lah. Because you see, when your output current is like one wave like that, it's not smooth lah. So how do you smooth it? Is using the capacitor like that lah. You smooth it. And then instead of dropping to zero over here, it will release the energy to smoothen it. And then smoothen it. So you see, it will produce a current like this lah. That means it's smoother lah. Like that, and then like that. Instead of dropping down to zero. Okay, potential different across R. Capacitor is connected in parallel to the load R. When the power supply is turned on, the output current becomes smooth. When the potential difference increases, capacitor will be charged and then energy is stored within the capacitor. Potential difference decreases, capacitor will discharge so that current does not fall to zero. That means dia akan release dia punya energy dalam situ lah, the voltage. Okay, so the energy stored in the capacitor will maintain the potential difference across the resistor R, and then smoothed output waveform shows that the capacitor is functioning as current smoother. Okay, that's all for capacitor. Can you understand? Okay, Faham ya? So you already learn semiconductor diode, you already learn capacitor, which is also rectification. Next, you will learn transistor. Okay. Okay. So transistor is, you have two types. One is NPN, one is PNP. N that means negative, positive lah. Okay. And then there will be three parts lah: collector, base, and emitter. Now you just remember, okay, for NPN, negative, it will emit electrons, right? So you see it's coming out lah. The arrow coming out macam tu. For PNP, positive, right? The electron will go in lah. Okay. So the collector, all this dia tak akan change punya. Dia akan CBE the same thing. Okay. Okay. Now, transistor is widely used. Now, what is the function of transistor? Transistor is basically to control the direction of the circuit, whether it will light up or not lah, based on the resistance. Okay. When the switch is open, bulb L1 does not light up as the circuit is incomplete and the base current is 0. Okay. You see, this entire circuit, there will be two parts. One is the base current, one is like the transistor current lah, over here. Okay. So you look at base current. Bulb L2 does not light up although the collector circuit is complete because transistor is not turned on, a collector current is 0. Okay. Kalau saya turn on ini, bulb L1 is dim because RB over here high resistance, base current very small. Okay, bulb L2 lights up very brightly because collector current is large compared to the base current. Sini collector current akan lebih besar daripada base current di sini because you see voltage 6 volt. Okay, base current can control the flow of the collector current. This enables the transistor to act as a switch lah. The resistance and the base current is large to limit the base current so that transistor will not become too hot and burn. That means sini, the base over here will activate the collector. Okay, now how do you see activate? Okay, current amplifier. Okay, before we move on to the activation first, you have to understand, okay, look at here, NPN transistor. Your current in the, if your current in the base is 0, you tak akan activate the transistor, so your current in the collector will be 0 lah. Okay, but your current in the base is always the smallest. Your current in collector will be in the middle, and then current of the emitter will be largest. So your gradient beta, okay, beta equals to current of the collector over the base current lah. Okay, that means you see straight line passing through origin. Okay, that means you see 156. That means base current sini 1 milliampere, beta my gradient, the amplifying factor, you will times 156. That means 1 milliameter in the base current is 156 milliameter in the collector current, collector circuit. Can you understand? Okay, this beta, what does this beta mean? Okay, yeah, I know this one actually, I also don't like this chapter because you really have to understand and read a lot lah. But unfortunately, you can only read yourself lah. Okay, you can only try and understand. I just hope that at least I help you all understand lah. Okay, understand this one, the mechanism. Ini memang kena memorize lah. Sorry lah, this one I memang also pray it didn't came out in exam lah. Okay, so it also uses the concept of voltage divider. What does it mean? This concept of potential divider method. That means, you see, transistor circuit, power supply or battery will supply a fixed potential difference. Transistor require a potential difference more than the minimum voltage for its function. In the potential divider method, two resistors with resistors should be connected in series. Okay, so your formula will be the one here, V out equals to the resistance here over the total resistance times the voltage. Okay, that means your V out, okay, you know your V out is this small specific region. So you take the R2 lah. The R2 is the specific region over the total resistance R1 plus R2 times the V in times the total voltage. Okay, this is the formula. Okay, now you look at the two different types of transistor. One is LDR, one is the thermistor. Okay, light dependent resistor is used in your light street light lah. Okay, light dependent resistor is a type of resistor. Its resistance changes with the intensity of light. Okay, LDR resistance value is high when light intensity is low. Okay. Resistance LDR akan high kalau dia dark. Okay. Resistance LDR low kalau dia bright on a sunny day. Okay, so you see, in the dark, LDR resistance is very high. Based on the concept of potential divider, voltage across LDR increase because you see, your voltage is directly proportional to your R2, to your resistance. When your resistance increase, your voltage akan increase. Okay, voltage akan increase, so will exceed the minimum voltage across B and E, base current will flow and turn on the transistor. Okay, this condition causes high collector current to flow in the correct circuit and bulb will light up. So at night, how do your street light up? LDR, resistance of LDR, night, when it's dark outside, nighttime, resistance of LDR is high. Because resistance LDR high, voltage for LDR is high. Kalau voltage LDR high, it can turn on the circuit lah. And then because of transistor, it will supply lah. It will turn up it will activate the bulb lah. But when it's daytime, bright condition, resistance low. Resistance low, voltage low. So dia tak akan activate lah the current. There's no base current flowing, so the bulb does not light up. Circuit is used in automatic street light. Okay? Kan lah? Ya, it's plain lah. Okay. Thermistor dia berbeza pula. Thermistor is a resistor. Tapi you see the position. Okay? Thermistor here is the collector. Dia sama dengan C. Dia di atas sini collector. Tapi LDR is E over here. That's why dia akan opposite. Okay? Thermistor is a resistor. Its whose resistance changes with its surrounding temperature. Resistance is high under room temperature. So, R for thermistor is high when under room temperature condition, low temperature. Okay lah, I say cold lah, so it's easier. Okay, cold. Okay, resistance for thermistor is high when it's cold. Resistance for thermistor is low when it's hot. Tapi dia opposite mechanism. Okay, this is why I'm also very angry lah because it's frustrated lah. You have to memorize like the light dia macam ni. Tapi untuk thermistor dia berbeza. Okay, so you see, as the surrounding temperature increases, you become hot. Okay, resistance become low. When it's hot, resistance is low. Okay, resistance is low, voltage across thermistor decreases. Based on the concept of the potential divider, when the voltage across thermistor decreases, you tengok, voltage increase pula. Ayo, because you see, this time, your thermistor, dia bukan R2. Dia di bawah sini. Dia R1. Okay? R1 is thermistor. R2 is LDR. Like I said just now, the LDR is connected to the E. The LDR, you tengok, is connected here to the E. But the thermistor is C. That's why thermistor is R1. Resistor, LDR is R2. Okay? So, kalau hot condition, resistance of thermistor is low, voltage akan naik kerana dia inversely proportional. Confusing kan? Sangat confusing kan? Okay, give you time to understand. Okay, give you time to faham. The most important thing, you have to know condition dia macam mana. Condition kalau dark, resistance dia macam mana. Kalau bright, condition macam mana. Cold, condition, resistance macam mana. Hot, resistance macam mana. Okay, based on the resistance, baru you faham. Okay, R2, directly ke inversely? R1, directly ke inversely? Kalau LDR naik, voltage pun akan naik. Tapi thermistor inversely proportional. Thermistor, kalau decrease the resistance, voltage akan increase. Okay, yes, very confusing, but try your best to understand lah. Okay, so when the value of VR exceeds the minimum voltage, okay, so result in a high collector current. That means when it's hot, it will activate thermistor. Hot akan activate thermistor, cold tak akan activate thermistor. Okay, dark, bright tak akan activate LDR. Okay, sorry, bright tak akan activate LDR, dark akan activate LDR. Okay, faham ya? Okay. automatic switch in temperature control system. Okay, that's all lah. Okay, habis our chapter. You understand? So chapter 5 is more to how you understand it. You have to read through and understand the concept lah. Okay, especially all these transistor. That's all for our class today. Do you have any question before we end the class? Please. Electromagnetic. You want to score in physics, always target the easy chapter like electromagnetism. Itu you can score. You boleh score di nuclear physics. Quantum physics also you can score there. Okay? Pressure also you can score because it's easy. Ini kalau your essay, you tahu explain semua ni, you go for this lah. If you tak tahu, you don't choose this question lah. What's the difference between left hand, right hand again? Left hand is used for kalau you ada battery, you ada power source, it's a normal current, you guna left hand. Kalau dia tak ada battery, tak ada power source, you will use right hand for induced current. Induced current, how you produce the induced current? Relative motion between your magnet and also your conductor. Okay. Induced current is not the normal current lah. It will be the opposite one lah, induced. Okay. So that's why you use right hand. Jangan guna salah tangan. Okay, so I think that's all for our class today. If you have any question, feel free to ask me anytime lah. So thank you for joining our class tonight. See you next time. Okay. Bye-bye.